We started with the nitrogen in the last lecture. We have completed some of the properties of the dinitrogen. Today we are going to start with the physical properties. We have seen some of the reactions already. I hope everyone remembers the periodic table. Yes, Vishwanath, Vishnu, Yazira, Shrutika, Akash, Parikshit, mnemonic. Should I ask? Should I ask? Should I ask the elements? Should I ask the elements? Yeah. Chalo. Tell me which is the first, not my wish. I am going to ask. Okay. There is no to that question. Okay. Chalo, tell me. Group 16. The second element in the group 16. The second element in the group 16. Second element in the group 16. Second element in the group 16. Correct, Vishnu. Correct, Parikshit. Very good, Vishwanath. Samantha is equal to sulfur. Samantha is an actress, no? What was that song, Vishnu? Vishnu, what was that song? Samantha is equal to sulfur. What was that song? I know you all have danced on it. Yes, Parikshit, isn't it? On that KGF, no, not KGF. Which one? Which movie it is? Which movie? I forgot the name of the movie. Pushpa. Pushpa. Yes. Answers never come out so quickly. Yeah, Vishwanath. But the name of the movie is instantly in which Samantha has danced. I did not even give the hint. Vishnu knows the name of the song. I was not talking about that song, Vishnu. Okay. Chalo, anyways. Then tell me group 17 third element. Group 17 third element. Yes, Yazira, Parikshit. Group 17. Group 17 third element. Correct, Parikshit. Correct, Yazira, Vishnu. Group 17 third element. Correct, Shrutika. Okay. Then group 13 third. Group 13 third element. Group 13 third element. Group 13 third element. Correct, Vishwanath. Correct, Vishnu. Very good. Correct, Shrutika. Then let us say it's not germanium, Parikshit. Group 13. It's gallium. Okay. Then let us say group 14 fourth element. Group 14 fourth element. Group 14 fourth element. Tell me the element symbol also. Tell me element symbol. Do not tell me the name. Tell me the symbol. Tell me the symbol. Tell me the symbol. Is it TN? Is it SB? Is it SN? What is it? Correct, Yazira. Correct, Shrutika. Correct, Vishwanath. Yes. See, I know most of the students get confused in this. Most of the students get confused in this. Parikshit has said SB. Parikshit, is it SB? Yeah. Vishnu, tin is not TN. It is, remember, it is stannous. Okay, tin is nothing but stannous. SN. Tin is stannous. Okay. Group 18 fourth element. Group 18 fourth element. Group 18 fourth element. We did not do any mnemonic for that. Group 18 fourth element. Vishnu is saying XC, Parikshit is saying KR. Tell me the final answer. Come on. Correct? Vishnu, in the group 18 there is helium also. Do not forget. You have to start from the helium. Yes, helium, neon, argon, krypton. Correct? It is helium, neon, argon, Krypton. I asked you the fourth element, correct? It is krypton. Is it clear? Very good. You remember the periodic table? Okay. Now, plus minus. Okay. Now, okay. Chalo. Let me try the electronic configuration. Let me try the electronic configuration. Suppose atomic number is 16. Atomic number is 16. Your last electron enters in which subshell? SPDF. Atomic number 16. Atomic number 16. Last electron enters in which subshell? I do not want P. I want 1P, 2P, 3P, 4P. That I want. Come on, write down the electronic configuration. Atomic number 16. Shrutika, is everything fine with the keyboard? Come on, tell me. Look into that diagonal, look into that triangle that we have made. Correct, Parikshit, correct, Vishnu. Good evening, Netra. Dharneshwar, I am not asking about shell. I am asking about subshell. SPDF. That is what I am asking about, Dharneshwar. Atomic number 16, the last electron enters in which subshell? Along with the quantum number. Along with the number. Which P, which D, which S. Correct, Sudarshan. Vishwanath, 5P. Is it? 5P. Oh my God. No. Atomic number 16. How you can go till 5P? It is 1s2, 2s2, 2p6, correct? 3s2, 2, 2, 4, 6, 10, plus 2, 12, and 3p4. 3p4. Correct? So the last electron enters in the p subshell. So in the last lecture, our most of the focus was on periodic table and most of the focus was on electronic configuration. Yes? Shalom. Now tell me, suppose, okay, now tell me what is the atomic number first of all. What is the atomic number of group 14 second element? What is the atomic number of, I am increasing the difficulty level. What is the atomic number of group 14 second element? Group 14 second element. What is the, I hope you remember that trick. Yeah. Group 14 first element, what is it? And then you add something to it, you'll get your atomic number. I'm not asking Sudarshan element, I'm asking atomic number. Yes, silicon is correct, Sudarshan, but I'm asking the atomic number. Correct, Dharneshwar. Correct, Yazira. Correct, Vishwanath. Parikshit. Yes, I hope you remember the trick. We take the first element and we add 8 to it, isn't it? So the first element, Vishnu, the question was, what is the group 14th second element's atomic number? Atomic number of group 14th second element. Correct, Sudarshan? Okay. Then group 16th fourth element. Again increasing the difficulty level. Group 16 fourth element. Vishnu saying 52, Dharneshwar saying 32. Yes, it is TE, but what is the atomic number? What is the atomic number? Again 34, 54, 52. Oh my God. So many numbers. So many numbers. Yes. Come on, tell me, is it 54 or is it 52? Give me the final answer. Yes, everyone? Group 16, fourth element. You have forgotten our rule. What is it? Our first element. of group 16 is what? Oxygen. What is the atomic number of oxygen? Vishwanath, Vishnu, Shrutika, Sudarshan. Atomic number of oxygen. Parikshit. Oxygen atomic number, not atomic mass. Atomic number. Atomic number is 8. Yes. To this 8, we add the 8, makes it 16. To this 8, what do we add? Correct? What do we add to this? Yes, we add 18. We will make it 34. To this, we will add another 18. Yes, we'll make it 52. Yes, isn't it? And to this, we add 32. Makes it 80. So first oxygen, then after oxygen, what we have? We have sulfur, we have selenium, we have tellurium. So it is atomic number 52. Is it clear, everyone? Yes or no in the chat box? Is it clear? I hope periodic table is clear to each and every one of you. Yes? Periodic table is clear to each and every one of you. So I hope if anyone asks the atomic number, electronic configuration, the last electrons, you will not fumble. Yeah? Okay. Okay. Now, tell me honestly, how many of you like to eat chips? Yeah? All those Lays and all this we get. Yeah? That is the favorite one. Which color Lays? Which color Lays? Mine is blue. Which color Lays? Blue. Oh, no. The yellow one is the normal one. Blue, then the cream and onion, the green one. Yeah? Orange. Okay. Mine is the blue and green. Yeah? Orange and blue. Yeah? Green and blue is the best one. My taste buds have evolved now. My taste bud has evolved. First, I started with the blue. Now I like the green one more. You know, fun fact, when I was a kid, what I used to eat for dinner, I used to eat milk, rice, and I used to get a packet of Lays, of the blue color Lays. So I will have little bit of masala flavor to it. Yeah. So milk, rice, and Lays I used to eat for dinner. Imagine when I was a kid, not now. When I was a kid of like 10 years, 12 years. Okay. So the question is not for the chips. The question is, we all know, like we say, Lays sell us the air, isn't it? The packets are so huge, but the chips, the crisps, which are inside are only 12 to 15, isn't it? Which air is that? Yes, it is filled with, correct, Vishnu, Parikshit. Sudarshan, CO2, no, not CO2. They do not feel it by blowing from the mouth. Do they feel from blowing from the mouth? Oh, let us take a packet of chips. We'll put the chips and then they will blow and they will zip it. Is it so? Hydrogen. Oh my God. Hydrogen. Hydrogen gas. Oh my God. Achha, you asked, but still hydrogen is explosive. Dharneshwar, hydrogen is explosive. Which gas they fill in the balloon, everyone? The balloon, the gas they have. Yes, Dharneshwar, which gas is that? Dharneshwar, it is not a hydrogen. What do you think hydrogen gas? Hydrogen gas is the most flammable gas. It is so difficult to handle the hydrogen gas. They do not fill it with the hydrogen gas. Okay. It is voice changer. It is helium gas. It is the helium gas. It is not hydrogen. Remember, Dharneshwar, hydrogen is an explosive gas. It is used to boost up the rockets that go in the air. Okay, we have that gas in the propellant, in the fireworks, what we have just to push the rocket up. So hydrogen is very explosive. It is not used in balloons. Okay, it is helium gas. And in the chips, Dharneshwar, we use the N2 gas. That is nitrogen. Okay, that is nitrogen gas, N2. So what is the use of gas in that? The use of gas is it gives the crispiness. The crispiness, yeah, the crispiness of the chips is maintained by what? Is maintained by that gas. is maintained by that gas. If that gas, if they do not put, the chips will not be crispy. Yeah, the chips will not be crispy. So your nitrogen is kind of an inert gas. Okay, nitrogen does not, N2 gas, I am talking about N2, not only N. I am talking about N2 gas. Okay, now N2 gas is slightly inert. Now what happens? So it surrounds the chips and it makes the environment inert. It does not allow chips to react with anything. So your chips remains fresh and you can eat it properly, you can enjoy it. Yes, is it clear everyone? Is it clear? Laughing gas, Vishwanath, laughing gas is nitrous oxide. Okay, laughing gas is nothing but nitrous oxide. We'll come to that. We have that N2O, correct, nitrous gas. Chalo. Yeah, dinitrogen is a colorless. Obviously, it is in the chips, so it is colorless. Otherwise, if we open the packet of chips, all the color will come out, isn't it? So it is colorless, odorless, tasteless. And that is why it is best to be used in the chips, because it is tasteless, colorless, odorless. So it will not react, it will not add any color, add any odor to the chips. It will not add any taste to the chips. That's why it is the perfect gas to put it in the Lay's packet, in all the chips packet what we have. Yes, it has two stable isotopes. Please write it down everyone. N14 and N15. These are the two stable isotopes. These are the two stable isotopes. Now tell me one thing everyone. Isotopes. Yes, isotopes. Tell me with respect to proton number and the neutron number. What are isotopes with respect to proton number and neutron number? Yeah. What are isotopes with respect to proton number and neutron number? Don't know. Acha, I'll come to this. Vishwanath, Vishnu, Yazira, Parikshit. Parikshit, I'll come to that. Yes. What are isotopes? Shrutika, Akash, Sudarshan. With respect to proton and neutron. Acha, you don't know with respect to, then tell me whatever you know. Write down whatever you know, the definition of isotope. Yes, everyone. With respect to proton and neutron, if I ask you, define isotope with respect to proton and neutron. What are isotopes? Correct, Parikshit? So you know it, no? Like, connect that definition to proton number and neutron number. Chalo. Forget about proton number, neutron number. Tell me simple, what are isotopes? What are isotopes? Vishwanath? What are isotopes? Shrutika, Akash, what are isotopes? Come on, tell me. Correct, Yazira. Correct, Vishwanath. Yes, what are isotopes? Everyone? Pawan, what are isotopes? Yes, got it, Vishnu. Akash, what are isotopes? Netra, what are isotopes? Yes, isotopes till now we have studied. Parikshit, till now we have studied. Isotopes are something that have same atomic number, correct? Same atomic number and different mass number, isn't it, Parikshit? Same atomic number, different mass number. Now, everyone, what do you mean by atomic number? How do you define atomic number? Atomic number is nothing but your proton number. No, Parikshit, it is not number of electron. I have told you in the last lecture. I guess you joined us late. Yeah. What is atomic number? Now, for example, Parikshit, for example, carbon. What is the atomic number of carbon, Parikshit? What is the atomic number of carbon? Everyone, what is the atomic number of carbon? Yes? Oh, Vishnu. Atomic number of carbon, not the valence electron. It is 6. Correct? It is 6. Correct? Now, if I remove an electron, Parikshit, if I remove an electron from the carbon, what happens? What do we get if I remove an electron? Let us say I have CH4 or any carbon compound. If I remove an electron, correct, Parikshit has answered it perfectly. That is, we get carbocation. So Parikshit, you tell me, if you are removing electron, now you are getting 5 electrons. So if your atomic number is your electron number, then why not we get boron then? Why C plus? Why not boron? Are you getting it, Parikshit? Are you getting it, everyone? Why we are getting then carbon positive, not the boron? Because Parikshit, your atomic number is not equal to the electron. Your atomic number is equal to the proton number. Yes, remember this, atomic number is equal to proton number. That means what, Parikshit? If the atomic number is 6, I have 6 protons. That is 6 positive. Over here, 1, 2, 3, 4, 5, 6. Correct? And to make the atom neutral, your atom exists because it is neutral. Your element exists, Vishwanath, because it is neutral. So to make it neutral, we have equal number of electrons. So 1, 2, 3, 4, 5, 6. Correct? So atomic number is the proton number. Okay, atomic number is the proton number. And that is the reason, Parikshit, if I remove an electron, my atomic number is same because the proton number is same. But now I have an extra positive charge over here, which is not neutralized. Are you getting it, Parikshit, Vishwanath, Vishnu? Everyone, is it clear? Yeah? Parikshit, is it clear? So, atomic number is nothing but proton number. Atomic number is proton number and mass number is proton plus neutron. Mass number is proton plus neutron. So, Parikshit, what are isotopes? Same atomic number. That means they have the same proton number, different mass number. That means they have different neutron number. Yes, everyone write it down. Those who do not know, isotopes are nothing but the same proton number, elements containing same proton number but different neutron number. Isotopes we know N14, N15. It is a non-toxic gas. Obviously, that is why we use it. It is slightly lighter than air and its vapor density is 14. Now tell me about helium. Helium, is it heavier or lighter? Yeah, then air, I am saying. Then air. Vishnu, Yazira, Vishwanath, Akash, helium, is it lighter than the air or is it heavier than the air? Yes? Dharneshwar, is it lighter than the air? Helium, I am asking about helium. Correct? I am asking about helium. Yazira, is it lighter than the air or is it heavier than the air? Correct. So we have the balloon, we have the helium balloon, isn't it? That goes in the air. Why? That goes in the air, that goes. Why? Because it is lighter than the air. If it was heavier, it will stay down, it will not go up. It will not go up. It has very low solubility in water. Yes, it has low solubility in water. Can you think of it? Why? Why does it have low solubility in water? Yes, everyone. Why it is having low solubility in water? What do you think, Vishwanath? It is lighter. Why it has low solubility in water? Yeah. Why N2 will have low solubility in water? If you remember, I had given you one statement. That like it will not react with water. Yes, that is why, that is what is my question. Why it will not react with water? Not exactly van der Waals forces. What happens? It has low solubility because like dissolves like, and N2 is kind of a non-polar because you have the same elements. Yes, you have the same elements. Correct, Yazira, you have the same elements. So it is like a non-polar in nature. So like dissolves like. Water is a polar solvent. So if you have a polar gas, then it will dissolve better. If you have a non-polar gas, it will not dissolve. Simple as that. That is why it has a very low solubility in the water. Is it clear, everyone? Is it clear? Yes, and that is the exact reason why it is neutral towards litmus, because dinitrogen is, inert in nature. It is neutral. It is neutral. Now it combines with non-metals. We will come to this Haber's process. We are coming to this. So let us do the Haber's process and the nitrite. So what we have, chemical property, it formation of metal nitrite. So whenever, write it down, important. Whenever we react N2 with the metal, N2 with the metal, N2 plus metal, what are we going to get? We are going to get metal nitrides. That is N3. Metal nitrides. Not metal nitrogen, it is metal nitrides. Yes, N2, sorry, metal nitrides. Now, depending on the what charge you have over here. So, N3. Yes, metal nitride. Metal nitride. Yeah, N3 minus. Look over here. Suppose I reacted it with lithium. Yes, lithium. What is the charge on lithium generally, everyone? What is the charge on lithium? Is it +1, +2, +3? Yes? Parikshit says +2. Come on, everyone. Come on, reply. What is the charge on lithium in general? Vishwanath says +2. Vishnu says +1. Lithium. Where is it present? Netra says +2. Netra, where is the helium? You all have forgotten. Hydrogen, helium, lithium. Isn't it? It is in the group 1. It is in the group 1. Lithium, atomic number 3. If I write down the electronic configuration, it is 2, 1 in the valence shell. Isn't it? So lithium is +1. And that is why you can see over here Li3N. If I react lithium and the nitrogen, you have to remember like this only. Balancing, you do it afterwards, but remember like this. Li plus N2, it will form lithium nitride. Li is +1. Therefore, I have 3 nitride, 3 lithium and 1 nitride. So, Li +1 3 times and -3 1 time to make it stable. Is it clear, everyone? Come on, give me yes or no. Lithium nitride. Yes. Li +1 and -3. So, it is like this. Li3 and lithium nitride. Same case over here. Magnesium. Magnesium, it is in which group, everyone? Magnesium is in which group? Which group of the periodic table contains magnesium? Come on, tell me. Yes, group 2. Perfect. That's why it is Mg +2, isn't it? That's why it is Mg +2. So let us say it is Mg +2. Nitrogen is -3. So cross. So Mg thrice N2. Remember like this. It will be easy to remember. Otherwise, it will be very, very, very difficult. It will be very, very difficult if you do not remember it like this. Is it clear, everyone? Come on, give me yes or no. Is it clear, Dhaneshwar? Okay. So over here, same case, Vishnu, what we have, calcium. Again, calcium is +2. Nitrogen is -3. Again, cross, that is Ca3 and 2. That is calcium nitride. Same thing over here, aluminum nitride, Al +3 and -3. So you do not have anything, it is Aln. Come on, write down this reaction quickly. Quickly write it down and done in the chat box. Reaction of nitrogen with metal. Parikshit is done. Vishnu is done. Reaction of metals with the nitrogen. Okay. Done. Let us go ahead. Okay. Now let us come to the most important part. Your Haber's process. Yes. Your Haber's process. Haber's process. Let us come to the Haber's process first. How do we prepare? On Haber's process? Basically, chemical properties means reaction with N2. Reaction with N2. Okay, dinitrogen chemical properties. How does it react? Now, Haber's process, in that we have Fe as well as molybdenum. Are both catalysts? We have done this in the surface chemistry. Fe and Mo, are they both catalysts? What do you think? In the product, we neither have Fe, neither we have Mo. Correct, Parikshit? Yes, Vishnu, Vishwanath, Shrutika. Fe and Mo. Fe and Mo are both them are catalyst inhibitors. Why we will inhibit the reaction? Why we will make it slow? If we have to make it slow, then we will not use catalyst only. FeMO, is it a catalyst? Both of them. We have done this in the surface chemistry. So out of them, yes, Fe is catalyst. Fe is catalyst. Mo is the promoter. Do not forget. Mo is nothing but the promoter. Mo is nothing but the promoter. That means it increases the activity of Fe. It increases the activity of Fe. Remember this. It increases the activity of Fe. Correct? So write down this Haber's process. So what happens in the Haber's process? The nitrogen gas and the hydrogen gas, they combine into 1:3 ratio to give you ammonia. To give you ammonia. And Fe is used as catalyst. Mo is used as the promoter. So if I react nitrogen and hydrogen, what do I get? I get the ammonia. Simple. Simple. Okay. Then if I react nitrogen with oxygen, everyone, if I react nitrogen and the oxygen, what I'm going to get? I'll get, simple again, nitric oxide. No. No means no, isn't it? Nitric oxide. Yeah. And if I do the further oxidation of nitric oxide, I'll get nitrogen dioxide. Get nitrogen dioxide. Okay. So what we have got, nitrogen if mixed with hydrogen, we will get ammonia. Nitrogen will mix it with oxygen, we will get nitric oxide. Further oxidize it to get the nitrogen dioxide. Is it clear, everyone? Come on, give me yes or no. Is it clear? Okay. Then what happens if it is reacted with carbides and oxides? Yeah, what happens if it reacts with the carbides and oxides? What will happen? Look over here, write down again important reaction with calcium carbide. If it reacts with calcium carbide, the nitrogen gas, we are talking about dinitrogen. If dinitrogen reacts with calcium carbide, we are going to get simply one carbon is simply thrown out, and what do you get? You get the calcium cyanide. Okay, or calcium cyanamide. Okay, so N2 directly gets added. N2 directly gets added. Similarly, if we did the both, if we have carbon as well as N2 reacting with aluminum oxide, again what are we going to get? We have already seen that is aluminum nitride. Is it clear, everyone, till over here? Come on, give me yes or no. Is it clear till over here? I know the chapter is little bit theoretical. We are trying to complete it as soon as possible. We will complete as soon as possible. Come on, write down. Come on, write it down and done in the chat box. But sir, for amide C double bond O, no. It is not like that. See, it is not cyanide. Cyanide, okay? It is cyanamide. It is cyanamide. It is like this. We have two nitrogen over here. Okay, we have two nitrogen, not a single nitrogen. Okay, so it is like this. Ca2 plus N double bond C double bond N. So this is also cyanamide. Okay, remember, calcium cyanamide. It is not Cn. It is not Cn. Okay, sure. Let us go ahead. Let us go to the as we have done. Let us go to the dinitrogen Haber's process. Let us talk about the dinitrogen. Now, obviously, it is used in the manufacture of compounds like your ammonia, Haber's process. So, let us talk about it. So, everyone, look over here. Look over here. Haber's process, we all know in simple we write Haber process like N2 plus 3H2. Till now, it must be by hearted to you. N2 plus 3H2 will give me 2 ammonia. This is nothing but our Haber's process. This is nothing but our Haber's process. Okay, formation of ammonia. Now the question is, how exactly it happens on the industrial level? How exactly it takes place on the industrial level? Let me show you. Look over here. How exactly does it take place on the industrial level? So this is the diagram. This is the diagram. How your nitrogen and hydrogen gets mixed. How nitrogen and hydrogen gets mixed. How nitrogen and hydrogen gets mixed. Okay, look over here, everyone. Look at this apparatus. This is your Haber's process apparatus. How does it look like? Look over here. We have the nitrogen, we have the hydrogen. We are mixing it in the compressor. We compress it, we allow them to react, and we let them go ahead. Then it goes ahead into the catalyst chamber. It goes ahead in the pump. Okay. First, no, it does not go to pump directly. First, what happens? It goes into the catalyst chamber. Now, in the catalyst chamber, what happens, everyone? In the catalyst chamber, we have nitrogen, we have hydrogen, we have ammonia. Ammonia from the reaction of N2 and H2. So, we allow it to pass it through the condensing pipe. So, condensing pipe will only and only condense the ammonia. Will only and only condense the ammonia. Okay, will only and only condense the ammonia. And it will allow some of the nitrogen and hydrogen which has gone out to again go into the pump, again continue and add that nitrogen and hydrogen into the catalyst chamber. Into that catalyst chamber. Is it clear, everyone? Is it clear? Simple. Simple. Do not make it complicated. Very simple. Is it clear? Okay. So what happens over here? Compounds of nitrogen present in small quantities of air, quantities in air and soil, it is formed by the decay of nitrogenous organic matter. So ammonia, we are preparing ammonia. Now ammonia is not only possible by your Haber's process, it is possible by some other methods also, like, everyone come on, write it with me. First is the urea. Please remember the structure of urea. Why student get so much of confused, I do not know. Urea is like this: NH2, C double bond O, NH2. Instead of RR group, what we have, Vishnu, we have the NH2. Correct? So this is urea. So when you hydrolyze the urea, you get the ammonium carbonate, that is NH4 2CO3, which you heat it, you will get ammonia. You will get ammonia as a gas. So this is how we prepare in the laboratory. In the laboratory, we do not do the Haber's process. In the laboratory, we do all this. Second, third, and the fourth. Okay, come on, write it down. First is from the urea. If I heat it, if I hydrolyze the urea, I'll get the ammonia. Then I have ammonium chloride and sodium hydroxide, which is nothing but a base. So what will happen again? NaCl will always and always come together. Your H2O will be released, and again your ammonia gas is formed. Similarly, ammonium sulfate reacting with the base, again ammonia is formed. Similarly, ammonium chloride reacting with the base, that is now calcium hydroxide, will get again calcium chloride and the ammonia. So salt and the ammonia, salt and the ammonia. Come on, write it down and say done in the chat box quickly. This is what we do on the small scale. On the small scale, you cannot set up a Haber's process apparatus. On the small scale, that means you are allowed to do some of the wastage. Yeah, just what you do in the salt analysis, isn't it, Vishnu? What you do in the salt analysis, all the test tube in the end directly goes into the basin. Yeah, isn't it? Like, have you ever wondered? We put all those chemicals directly into the basins. The pipe, it must be carrying all the chemicals all the way to the river or something like that. It is so harmful. Yeah, it is so harmful. But we have a habit of throwing it directly into the basin. Isn't it, Vishnu? No, what? No. Then what do you do? I used to do it myself when I was not aware of all this thing. Come on, write down 4 reaction and that in the chat box. Keep it there and come. Okay. Come on, write down in the chat box. Done, done, done. Vishnu is done. Yazira is done. Kritika is done. Sai is done. Pawan is also done. I titrated the solution very hardly. It was very hard to bring the correct measurement and pink color after I made my ma'am poured it. See, that is the thing. No, we should not actually pour it. Now, some of the colleges have the treatment plant, okay, where they keep all the chemicals and they remove all the harmful particles that are present in the chemicals. But all the colleges, all the schools do not have that. Okay. So only put anything into a wash basin when it is allowed by a teacher. Okay. Do not put sodium metals into the basins. Yeah, isn't it, Vishnu? Do not put the sodium metals into the basin. In the sink. Basin is in sink. Yeah, it will give you a pop noises, but it is not good. Yeah, then write down this also. You have written all the preparations, so write down this also from magnesium nitride. If I hydrolyze it, what I am going to get, everyone? Ammonia again. Magnesium nitride. If I hydrolyze it, I am going to get, obviously, see, whenever you have the group 2 metal and if you are hydrolyzing it, yeah, we will always and always get hydroxide. Nothing else is possible. Always and always, if you have group 2 element and you have water, always and always a base regarding to that you will get. Okay. So magnesium nitride, if I hydrolyze it with water, what I'm going to get? Magnesium hydroxide and the ammonia gas. I have only done practicals once in my life, sir. I don't have any knowledge about that. Okay, no issues, Vishnu. You will get it soon. When you go to engineering, you'll get it. In the first year of engineering also, you have the chemistry. Yeah. Do not forget, Vishwanath. Yeah. First year of engineering, it also has chemistry. Obviously, P block is not there. And I teach that also. I have some of the students who failed in the chemistry. They came to me after they failed in their engineering exam, the semester, okay, and I had taught them. Sure. Haber's process, what happens? Everyone, reversible exothermic process. It is a reversible exothermic process, okay. Then it is done at the low temperature. 700 Kelvin is not low temperature, but for the large scale Haber's process, we use it for the commercial scale. Yeah, for the large scale, it is still less. Okay, it is still less. High pressure, presence of catalyst. In that catalyst, yeah, presence of catalyst. Is it clear, everyone? I hope nothing is there. I don't think so. Any doubt you should have in that? Is it clear? Okay, let us do the okay. Let us go ahead. Ammonia properties, the physical property. Ammonia. How does ammonia smell? Yeah, Vishwanath, Vishnu, Yazira. How does ammonia smell? Yes. How does ammonia smell? Do not say ammonically because it is written over here. Do not say ammoniacal. Vishwanath has given us a very detailed description of it. Old socks with the citric fruits. Ah, old socks with the citric fruits. Do not write that. Okay. When it is pungent, it is very bad. I know it is very bad smelling. Okay. Yes, Vishnu, I get it. So ammonia, it is, do not say if your examiner Viva teacher asks you how does ammonia smell, do not say a soft, yeah, he will not like it. It is pungent. It is pungent. It is very bad. Okay. It is lighter than the air, again 0.68 gram per cm cube. It is highly soluble in water. Why? Because ammonia is a polar molecule. Simple. Highly soluble in water. The high solubility of is due to the intermolecular hydrogen bonding. Ah. Intermolecular hydrogen bonding. Come on, everyone, tell me what is intermolecular hydrogen bonding? Yes. Intermolecular hydrogen bonding. What is it? Hydrogen and hydrogen bond. But between whom? Sudarshan, between whom? Intermolecular. Intermolecular hydrogen bond. What do you mean by that? Come on, everyone. Yes, correct, Sudarshan. Hydrogen inside the same molecule, is it? Is it the same molecule or the different molecule? You are still confused with the inter and intra. I had given you the example. To remember. Yes, inter-school and intra-school. We play inter-school, Parikshit. Inter-school means what? Is it in the same school or is it with the different school? Yes, Parikshit, inter-school. Is it with the same school or the different school? Yes, it is the different school. Exactly. Intermolecular hydrogen bond. That means it is a different hydrogen. What do I mean by that? Look over here. Nitrogen, hydrogen, hydrogen, hydrogen. This is ammonia. Parikshit, nitrogen is electronegative. So slight negative, slight positive. Then you have the water molecule, which is also polar. So over here, this is the hydrogen bond, intermolecular hydrogen bond. That is why it is highly soluble. Is it clear, Parikshit, Netra, Yazira, Vishnu? Is it clear, Vishwanath? Not a covalent bond, it is a hydrogen bond. Over here, sharing of electrons is not taking place. It is a hydrogen bond. It is just the force of attraction, nothing else. It is not a physical bond, it is a force of attraction. Okay, let us do the properties. It is basic in nature. Who told us? It is a Lewis base. Yeah, it is the Lewis base. And what is the function of base? Yazira, Vishwanath, Vishnu, Akash, Parikshit, Netra, Shrutika, Sai, Sudarshan. What is the function of base? What does a base do? Yeah, what does a base do? What does a base do? Yes, everyone. Do not give me answer in terms of Lewis. I know it is written over here, Lewis base. I am talking in terms of organic. Tell me, what happens when you put a base on a base? Yeah, just give me a minute, everyone. Come on, write your answers in the chat box. Yes, in the organic chemistry, what is the function of a base? It releases hydroxide ion. What else? If I put a base in any organic chemical molecule, if I have any organic molecule, if I put a base, what will happen? It makes acid to neutral. See, the role of a base always and always, always and always is to remove a proton molecule. Okay, it's to remove a proton molecule. That is why you can see over here. Yes, if NH3, how do we know it is a base? How do we know it is a base? NH3, okay, look over here. First reaction, NH3, they have put water. What is the role of takes the proton? Acid gives the proton, Vishwanath. Parikshit, isn't it? Acid gives the proton. Base takes the proton. So base has taken the proton, NH4 plus OH minus, ammonium hydroxide. Are you getting it? Similarly, NH3HCl, it has taken the proton. So NH4 plus, you have Cl minus. Similarly, over here also, NH3 plus, HSO4 minus. Yeah. So always and always base abstracts a proton. Okay. And in the Lewis base, we know according to the Lewis, base gives the electron. Remember it by the lone pair it has, it donates the electron. That's why it is a base according to the Lewis. Yeah, and that is how it forms the complex. How does it forms the complex? Complex means I have a metal, yes, NH3 will put the electron into the empty orbitals and you will get the complexes. Yeah, we will come to this in the coordination compound, do not worry. Yes. Okay, is it clear everyone? Complexes. For example, if I have formed the complex like this, silver tetra ammonia, okay, Ag NH3 4 2 plus. Yeah. Similarly, Cu2 plus, if it reacts with ammonia, it will form a complex. It will form a complex. Yeah. Then similarly, different types of, this is not Cu, this should be cadmium. So cadmium, if I react it with ammonia, I'll get the cadmium complex. No need of writing it down. Just write this down. Acha, my voice is stuck. Just a minute, let me refresh it. Is it fine now? Is it fine? Am I audible properly? Okay. Look over here. Yeah. So we have the complexes where I was. If I react, again I'll go back. Again I'll go back little bit. So it acts as a Lewis base because it donates the electron. Here ammonia act as a Lewis base because it donates the electron. Yes. Remember this. Then if I react ammonia with any metal, then it forms a metal complex. It forms a metal complex. Why? Because again ammonia has the tendency to donate electron to the metal and it forms a complex. Simple as that. Okay. Simple as that. Okay. Then we have the properties. Okay. Oxides of nitrogen. Okay. Chalo. So let's take a 5-minute break. Not 5 minutes. So let's meet at 8:10. It is 8:02. Okay. Let's take a small break. Everyone, do not leave the session. Come back quickly. Okay. Please do not do late. Is everyone back? Come on, back in the chat box. Come on, turn on your cameras. Netra, Vishnu, Sudarshan, Yazira, Parikshit, Vishwanath, Sutika. Turn on your cameras. Okay, Vishwanath. Come on, everyone, back in the chat box. Yes, turn on your cameras, everyone. Vishnu, Netra, Yazira is back. Sudarshan, Parikshit is back. Shrutika. Yes, Yashadeep. Okay, chalo. Let us go ahead, everyone. So always remember, if I have ammonia or any ammonia compound, what will happen if I react it with metal? It will form a complex. Similarly, look over here, AgCl, it is not NaOH, it is NH4OH. Yes, ammonium hydroxide. So what will happen? It will form a ammonium complex. Remember, ammonium complex. That's it. Similarly, copper, again I reacted it with ammonium hydroxide. What will happen? It will form a ammonium complex. Okay, this is what you have in the coordination chemistry. Sure. Let us go ahead. Now look over here, important. Mark this reaction important. Action with halogens. Action with halogens. Okay. Now look over here, everyone. Look over here. Suppose I react ammonia with the halogen. If I react ammonia with the halogen, for example, I am reacting ammonia with the chlorine. Okay, if I am reacting ammonia with the chlorine. So if I have more amount of ammonia, important, this reaction can come in the exam. Look over here. Ammonia reaction with chlorine. Okay. So if I have ammonia and chlorine, okay, and I react ammonia and chlorine, if I have excess of ammonia and chlorine is in the small quantity, then what will I have? I will form the ammonium chloride. Look over here, everyone. If I have ammonia in the large quantity, write down this reaction, ammonia plus chlorine. If I have ammonia in excess, okay, ammonia in excess, reacting it with chlorine, what I will get? I will get ammonium chloride. Your ammonia will be dominant, you will get ammonium chloride. If I have chlorine in excess, then all of the hydrogen will be replaced by chlorine. All of the hydrogen will be replaced by chlorine and I will get NCl3. I will get NCl3 and byproduct will be HCl. Over here, N2 gas will be released. Over here, N2 gas will be released. Come on, write down this two reaction, important. If I have ammonia in excess, I will get ammonium chloride. If I have chlorine in excess, I will get nitrogen trichloride. Come on, write it down. Write it down, everyone. And that done in the chat box. And turn on your cameras, Netra, Shrutika. Come on, write down the reaction, everyone. Yes, same thing over here. You can see if ammonia in excess, then ammonium bromide. Yes, if bromine in excess, then tribromo-ammonia or nitrogen tribromide. Yeah, and they are 3. Is it clear, everyone? Come on, write it down. And done in the chat box. Only Yazira and Parikshit has written done. Vishnu, is it done? Netra, Vishwanath, Shrutika, is it done? Write down these two reactions, important. It can come in exam. If it is in excess, what you will get. If chlorine is in excess, what you will get. Okay. Then if it reacts with iodine, yes, we will form nitrogen triiodide. It is not NH3NH3, it is nitrogen triiodide. Same thing again if I have ammonia and I have iodine. Now this excess thing was only for chlorine and bromine. Remember, this excess thing is only for chlorine and bromine. If I have NH3 and iodine, I will get, yes, I will get nitrogen triiodide. That is Ni3 plus 3H. Ni3 plus 3H. Okay. Only for bromine and chlorine, we have that excess and your deficient reaction. Okay. But if I have iodine, I will get always and always nitrogen triiodide. Nitrogen triiodide. Okay. And if I again react that triiodide with ammonia, if I again look over here, if I again react that, it is reaction. If I again react ammonia with the triiodide, I get a very explosive reaction. The complex is very explosive. Okay, it explodes violently and it releases the nitrogen gas and iodine gas. Okay, it releases the nitrogen gas and iodine gas. After the lecture, please look at all this reaction and once write it down in your book so that you will remember in the exam. Otherwise, everything will be forgotten. Trust me, it is very difficult to remember this. You have to write and remember. That is why people are irritated of P block, but we have to do it. We do not have any option. Yeah. Then we have oxides of nitrogen. We have done this a little bit. We have done the oxidation states of all of the oxides of nitrogen, correct? So N2O, your nitrous oxide. Yes, it is a unreactive gas. It is kind of an inert gas, does not react with anything. It is neutral, it is colorless. It is neutral, it is colorless. Again, NO, it is colorless, it is neutral. N2O3, yes, N2O3 having oxidation state +3. We all know why it is +3. Come on, calculate. If nitrogen, I am calculating the oxidation state, I'll take it as X. So 2X, 1 oxygen is -2 into 3 -6 is equal to 0. 2X is equal to 6. X is equal to +3. Yes, that is N2O3. Again, it is, remember, N2O, NO are neutral. N2O3 is acidic. So +3 N2O3. Write it down, everyone. Important. It is there in the class assessment also. Unstable. Your N2O3 is unstable. N2O3 is unstable. Similarly, N2O4, again it is acidic, acidic, acidic. So only and only remember N2O and NO are neutral. Remaining all of the nitrous oxide, all of the oxides of nitrogen are acidic. All of the oxides of nitrogen are acidic. Yes. And which are the unstable one? You have N2O5, which is unstable gas. Yes. And what was the other one? Your N2O3. So N2O5 and N2O3, write it somewhere on the top. Important. They are unstable gases. They are unstable. N2O3 and N2O5 are unstable. Unstable. Is it done, everyone? Come on, tell me. Write down this N2O5, N2O3. Unstable. Noted. Come on. Note it down. Okay. And also remember, N2O and NO are only two with the neutral and remaining are the acidic. Remaining are the acidic. Okay. Remaining are acidic. So again, I am telling you, after our lecture gets over, please sit for some time, again go through the PPT. You will get this PDF as a note. Please go through it once again, otherwise you will forget each and everything. Okay, you have to make your own notes for this. You have to write down the reactions and you have to do it little bit on yourself, otherwise it is not possible. Okay, sure. Let us go ahead now. Okay, today now after this we are going to go with the, yes, we are started with the nitrogen, correct? Now let us go to the nitric acid. Let us move to the nitric acid. Yes, let us talk about nitric acid. Yes, this is what we have done just now. Now everyone, please remember these names. Remember this name, hyponitrous acid. Come on, write it down. Name and the formula. Name and the formula. Write it down, everyone. Name and the formula. Hyponitrous acid, it is nothing but H2N2O. Hyponitrous acid, H2N2O2. H2N2O2. Okay. Then you have nitrooxalic acid. Nitrooxalic acid, H4N2O4. Nitrooxalic, oxalic, not oxalic, oxalic. Nitrooxalic acid. Okay, then we have nitrous acid, that is HNO2. Then we have nitric acid, that is HNO3. Then we have peroxonitric acid, that is HNO4. So two are unstable over here. Write down the name. Nitrous acid is unstable. Write it down, note it down, everyone. Nitrous and peroxonitric. Nitrous and peroxonitric acid is unstable. Okay, it can come in exam which is stable, which is unstable. So you should remember nitrous acid. Come on, write it on the top of your book, everyone. Write it on the top of your book. Nitrous acid, that is HNO2, is unstable, and peroxonitric acid, that is HNO4, is unstable. Come on, write it down and done in the chat box. Come on, write it down. Come on, only half an hour is left. Focus. I know theoretical, but we have to finish this. Come on, focus, everyone. Write it down and done in the chat box. Come on, write down the name, write down the formula, and write down which are the unstable ones. Write down the name, write down the formula, and write down which are the unstable ones. Come on, write it down and done in the chat box. Netra, is it done? Pawan, Sakti, is it done? Shrutika, is it done? Vishnu, is it done? Okay, Parikshit is done. Vishnu is done. Netra is also done. Okay, so let us go ahead. Okay. Now synthesis of nitric acid. Pawan is also done. I hope everyone is done. Yes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Chalo. Synthesis of nitric acid. Again, important one. How do we prepare nitric acid? Nitric acid is nothing but HNO3. Correct? Nitric acid is nothing but HNO3. So how do we prepare nitric acid? Yes, how do we prepare nitric acid? Look over, everyone. We heat sodium or potassium nitrate. Yes, We heat sodium or potassium nitrate. So when we heat sodium and potassium nitrate, we require H also. So that H we get it from sulfuric acid. So if I mix sulfuric acid and sodium nitrate like NaNO3, yes, what will happen? I have Na, I have NO3. So this is plus, this is minus. Similarly, H2SO4, that means I have H plus, I have HSO4 minus. So what will happen? NO3H plus comes together to give you HNO3. Na plus and HSO4 minus come together to give you a complex. Is it clear, everyone? Yes or no in the chat box? Is it clear? How do we prepare HNO3? Yeah. So what we have done, reacted it with sodium nitrate, or we can even take potassium nitrate. We can even take potassium nitrate. So react sodium nitrate and H2SO4, you will get HNO3. Simple. Simple. Okay. So this is how we get the HNO3. This is how we get the HNO3. Okay. So after HNO3, what we have, this is how we prepare HNO3. Then again we prepare HNO3 from NO2 also. Okay. Remember everyone, HNO3 we prepare from nitrogen dioxide also. But how do we prepare nitrogen dioxide? Look over here everyone, focus. How do we prepare nitrogen dioxide? First we take the ammonia. We just oxidize the ammonia. When you oxidize the ammonia, what do you get? You get the nitrogen monoxide. You go on oxidizing it. From oxidizing nitrogen monoxide, you will get nitrogen dioxide. So when you hydrolyze the nitrogen dioxide, what you will get? You will get ammonia. No, you will get the nitric acid. Come on, write it down from the first reaction, everyone. Ammonia, when you react it with oxygen, oxygen, what are you going to get? Nitrogen monoxide. So when you react ammonia in the oxygen, you get nitrogen monoxide. Yes. You further oxidize it. What are you going to get? You are going to get nitrogen dioxide. Then you further hydrolyze it. You will get HNO3. Come on, write down the first reaction. Ammonia, if you oxidize it, what you will get? You will get nitrogen oxide or nitrogen monoxide. Yes, write down the second reaction. NO react, again you oxidize it further, you get nitrogen dioxide. Then you hydrolyze it, you will get the ammonia. Simply add NO2 in water, you get the nitric acid. Not ammonia, so sorry, you will get the nitric acid. Come on, write it down and done in the chat box. Come on, write it down. Done in the chat box. And turn on your camera, everyone. You know, if I turn on your camera, you look like what, you know? I'll show you what you look like if I turn on the camera. Exact same face I could see. Yes, Sudarshan? Yeah, exact same face. No difference. Yeah, no difference. Little bit of theory starts. Okay, little bit of theory starts which does not have. Yes, obviously. How many of you all have pet dog? Anyone? Because I have one. Oh, Parikshit has it. I have adopted one. Okay. I have a stray dog who is now adopted. Name is Goldie. The name is Goldie. How much dogs? I have only one dog. Actually, we did not plan it. We did not plan it. We just brought it so that like he was injured. We rescued him. Okay, we rescued him. His actually he was a very small, like he was a puppy of 1 month maybe. Okay, so what happened? Suddenly a rock fell on his leg, and his leg became flat. So we were like, we will take him home and we will do all the medicine stuff and we will again leave him. But once you bring a dog or a pet home, okay, you will never leave him or her. Okay, so finally we adopted only. Okay, so do not be like this. Okay, do not be like this dog. Okay, I know it is a theory part. Okay, I know it is a theory part. Chalo, let us go ahead. Yeah, is it done, everyone? Come on, done in the chat box. Is it done? The two reactions, are they done? Okay, sure. Let us go ahead. Okay, preparation. Now, this was what we do in the laboratory. This two preparation, your NaNO3 H2SO4, I get HNO3. Yes, from the ammonia, I get the HNO3. This was your laboratory preparations. Yes, come on, give the heading to this, laboratory preparations. Okay, this is what we do in the laboratory. In the laboratory, wastage is allowed because we require only small amount. But when you do it commercially, the wastage is not at all allowed. Correct? So commercially preparing HNO3, we have Oswald process. Commercially to prepare HNO3, we have Oswald process. Come on, give the heading, everyone. Oswald process. So commercially, this can come in the match the following. This can come in the, JEE. So remember Oswald process. Oswald process. Okay. So what we did know, this last one actually, this first is a laboratory preparation. The second one is the Oswald preparation. Okay, Oswald method. So again, let us revise what we had done in the Oswald process. First, we had taken ammonia. If I oxidize the ammonia, everyone, what I am going to get? If I am oxidizing the ammonia, what I will get? NO and H2O, correct? If I, in the second step, if I further oxidize the NO, what I'm going to get, everyone? Come on, reply in the chat box. If I further oxidize the nitrogen monoxide, Vishnu, Sudarshan, Sai, Pavan, what I'm going to get, Shrutika, Parikshit, Yazira. If I further oxidize the NO, correct Vishnu, correct Parikshit. Yes, what I'm going to get, Sai, Shrutika, come on, reply. Nitrogen monoxide, if I further oxidize it, what I will get? I will get nitrogen dioxide. Yes, and in the last step, we just add the HNO3, H2SO4. Further add the H2, not H2SO4, so sorry. Further add the water. Yes, if I add the water, what I'll get? HNO3. I'll get the HNO3. Is it clear, everyone? Is it clear? Okay, so this, write down this reaction. This is for your Oswald process. This is your Oswald process. This is how you prepare HNO3 using Oswald process. So let us go ahead. Now physical properties of nitric acid. Now HNO3. Yes, is it a gas? Is it a liquid? What is it? Yes, HNO3 at normal room temperature. What is it? Come on, everyone. Is it a gas? Is it a solid? Is it a liquid? Yeah. Yes, HNO3. Yes, correct Vishnu, correct Parikshit. It is a liquid at room temperature. Okay. It is a liquid at a room temperature. Now HNO3 is a very strong nitric acid. Okay, like it is stronger even than your sulfuric acid. Okay, stronger even than your sulfuric acid. Nitric acid, once, in the nitration, what do we mix in the nitration, everyone? What do we mix in the nitration? Yes, what is nitrating mixture? Parikshit, Shrutika? Yes, all my organic people. Organic people. Nitration, what do we mix in nitration? The nitrating mixture. What is nitrating mixture? Shrutika, Sai, Vishnu, what is nitrating mixture? Yes? What is nitrating mixture? We mix HNO3 and H2SO4. Okay. So while doing nitration, we mix, this is called as nitrating mixture. We will do in the organic, do not worry. This is your nitrating mixture. So what happens, when you mix it, you get an electrophile NO2. Okay. So in the lab, well, I was carrying out this nitration reaction. In my masters, I was carrying out this reaction. Okay. And I was wearing a good Vans shoes. How many of you know Vans brand? Okay. At my time, it was very, very famous. Okay. Like the skater board players and all those players used to wear that Vans, and it was very trending shoes. Okay. And it was costly also. And it is generally made up of cloth. Okay. It is a canvas shoes made up of cloth. By mistakenly, only one drop of this fell on my shoe. Okay, one drop of that nitrating mixture fell on my shoe. Okay, while transferring it to another flask, one drop fell on my shoes. Immediately, I could see, I could see from that hole which is made in the shoe. Immediately, that cloth on the top of the shoe got burnt and it made a hole on it. Okay, so HNO3 is a strong acid. Okay. Vishwanath, let it end completely. What did parents tell? Nothing. Parents, I did not tell them at all. Okay. After some months, they got to know about it. Till then, it was already very late. How could I tell them? Like, they had got me a good pair of shoes and I burned them. Okay. Shall everyone come on? Nothing happened to my leg, luckily. Just a minute, everyone. Luckily, my leg was safe. It was not hurt. Yeah. Come on, everyone. Look over here. So nitric acid, it is used as a strong oxidizing agent. Come on, write it down. It is a concentrated acid. It is a strong acid. It is used as a oxidizing agent also. For oxidation reaction, we use the HNO3. Come on, write it down. It is used as an oxidizing agent. Yeah, HNO3 is used as the oxidizing agent. The question can come, out of the following, which is used as the oxidizing agent? So HNO3 is used as the oxidizing agent. Yeah, it reacts with most of the metal except noble metals. Now, HNO3 is so strong, we even dissolve some of the metals in it. Yeah, your gold and all that, we even dissolve that in the HNO3. It is so strong. Yeah, it is so strong. Okay, look at the reaction. Come on, everyone, look at this reaction. Important again. This reactions, anything can come from this reaction. Look over here. I want everyone's focus on the screen. Look over here, everyone. Reaction of nitric acids with metal. Now, if you remember NH3, what had happened if I reacted ammonia with the water, everyone? Ammonia acted as a base or an acid. Yes, everyone, ammonia acted as a base or acid. When I reacted ammonia with the water, yes, it is a base. Now, what is the role of a base? Vishnu, Parikshit, Shrutika, Sudarshan, Sai, Pavan, what did I tell you, Vishwanath? What is the role of a base? Netra? It gives or takes. It gives proton or it takes proton. Yes? Correct, Vishwanath? It takes the proton. It takes the proton. So it takes the proton from H2O it makes it NH4 plus. Similarly, HNO3 is an acid. And what is the role of an acid, everyone? It is to give the proton. That's why if I react HNO3 with water, what is going to happen, Parikshit? Your HNO3 will give the proton because it is an acid. So what I'll get? H3O plus plus NO3 minus. Is it clear, everyone? Come on, yes or no in the chat box. So it is a proof that HNO3 is an acid. Yes. Now it depends on the reaction. Are you taking a dilute acid? Are you taking a concentrated acid? Okay, depending upon that, you will get your product. So see, when you react nitric acid with any metal, one thing is sure, look into the products. One thing is sure, rather it is concentrated, dilute, doesn't matter. You are going to get NO3 twice, NO3 twice, NO3 twice. Doesn't matter what it is. Doesn't matter what metal you are getting. You are using dilute, concentrated. Doesn't matter. Yes, NO3 you will add it. Simple as that. Because from HNO3 you have NO3 minus from the metal, which is generally plus. Okay. So your NO3 gets added to the metal. Come on, write down one reaction only for the copper. Come on, write it down. For the copper, if I use dilute HNO3, I am going to get CuNO3 2. Only difference is over here I am getting nitrogen dioxide. If I use the concentrated one, sorry, over here look everyone on the screen. If I use the dilute, I am getting nitrogen monoxide. But if I use the concentrated one, it will oxidize the nitrogen monoxide also. What are you going to get? Nitrogen dioxide. That is the only difference. Dilute will not oxidize nitrogen oxide, that is nitrogen monoxide, but concentrated will oxidize the nitrogen monoxide also. Is it clear, everyone? Is it clear what is the difference between dilute and concentrated? Your HNO3 act as a yes, oxidizing agent. Your strong acid act as an oxidizing agent, not the dilute acid. So strong acid oxidizes this NO also, and it converts it into NO2. That is the difference. Come on, write down one reaction. One set of reaction, either copper or zinc. Come on, write it down and done in the chat box. Write it down, Shrutika. Sudarshan, write it down. Sakti. Again, Sakti, you are on the same position. Change the screen. What were you doing, Sakti? I know the lecture is a little bit boring in theory, but that does not mean you will do time pass by going to the other web page. Okay. If you want to do that, you can leave the session. You are welcome. But do not change the web page. I know when someone changes the web page. Yeah. Okay. Come on, write it down and done in the chat box. Copper. Write down for the copper both the reaction. Write down for the copper. And done in the chat box. Okay. Let us go ahead. Now look over here. What happens when nitric oxide is reacted with the elemental? Okay. All of the nitric oxide, as I told you, all of the nitric acid, not nitric oxide, all of the nitric acid, always and always, it is what? Nitric acid, concentrated nitric acid is a oxidizing agent. It will always and always form a oxide. It will always and always form a oxide. So nitric acid is an oxidizing agent. It will form a oxides. Correct, Sakti? It will form oxides. The nitric acid will form oxides. So over here, what will happen? I have carbon. Yes, if I react it with the nitric acid, Yes, everyone, carbon reacted with the nitric acid. What is going to form? Again, it is going to add the oxygen, carbon dioxide. Yes. So if you notice over here, all of the nitrogen, what is the product? Everyone, all of the nitrogen is getting converted into NO2. All of the nitrogen converted into NO2. All of the nitrogen. Yes, everyone, it is getting converted into NO2. Is it clear, everyone? Come on, write down this reaction. This reaction came in the last exam. This reaction has come in one of the exams. They had asked how many moles of NO2 do you get? Over here, balancing is important. How many moles of NO2 do you get? It is 48 moles of NO2. Imagine. Yeah. So one trick is the number of moles in the reactant, same you'll get for in the product. 4 HNO3, 4 NO2. 48 HNO3, 48 NO2. 20 HNO3, 20 NO2. Yes. So if I oxidize iodine, carbon, sulfur and phosphorus, again I will get what? NO2, NO2, again a common product. Is it clear, everyone? After the lecture, this is your duty. I am telling you again, you have to write down these reactions. I cannot wait for you to write each and every reaction. So after the lecture, Sakti, Sai, Parikshit, Vishnu, are you getting it? You have to write down the reaction. Yeah? You have to write down the reactions. I can tell you the trick and hints. Like for example, over here, everything is, you are getting is NO2, NO2, NO2. Yeah? Everything what you are getting is a NO2. So please, it is your duty to write it down after the lecture. Do not miss it. Okay? You have to take it seriously. Hardly 4-5 months are left. You have to give it your all. Otherwise, there is no use of studying so hard for a year. Attending the lecture, you could have easily done the time pass. You could have easily seen the movie. But you are attending the lecture, so give some effort and do it seriously. Okay? Chalo. So properties of nitric acid. Let us go to the chemical properties. Let us see the reactions of nitric acid. Yeah. So this is actually the test for nitric acid. So what happens if I have Fe2 plus, and I add the nitric acid. Fe2 plus to Fe3 plus. Is it oxidation or reduction, everyone? Is it oxidation or reduction? Fe2 plus to Fe3 plus. Yes? Is it oxidation or reduction? Sakti, Sai, Shrutika. Is it oxidation or reduction, Vishnu? Yes, Fe2 plus to Fe3 plus. What is it? Yes, it is nothing but a oxidation. And this is how you have to remember the reactions. Vishnu, Parikshit, Sakti, this is how you have to remember the reactions. This is how you remember the reaction. You have Fe2 plus, you know that HNO3 is an oxidizing agent, so it will oxidize the Fe2 plus. Are you getting it, everyone? Are you getting it? This is how you remember the reactions. Otherwise, it is very difficult. Okay. Then nitric acids. Where do we use it? Nitric acid. Yeah. How many of you know TNTs? Anyone? TNT. Yeah. In the cartoon. Yeah. In the Bugs Bunny, it was the bombs. In the Bugs Bunny, it was very famous, isn't it? Yeah. Correct, Sai? How many of you remember that Bugs Bunny cartoon? Anyone? Anyone? Any chance knows the Bugs Bunny? Tom and Jerry also. Yeah, it is in the Tom and Jerry also. Correct. But in Bugs and Bunny, the Looney Tunes. The Looney Tunes. Correct. They used to write that, red box, a TNT. It used to have some pressure pump. Yeah, if you press it, boom. And there was one ad also, Ambuja Cement, if anyone knows it. Augie and cockroaches. Do not give me reference of Augie and cockroaches. Ambuja Cement, that ad, that uncle, yeah, explodes the TNT. Uncles become black, but the wall is still standing. Yeah. So what is that TNT? What is the full form? Till now we know TNT. It is trinitrotoluene. trinitrotoluene. Yes, TNT is nothing but trinitrotoluene. Yes, it looks like this. This is your toluene, CH3, trinitro, NO2. Yes, NO2, NO2. This is trinitrotoluene. Yeah, that is a TNT. So it contains what? N, nitric acid. Yes, so it is used in the making of trinitrotoluene. Nitric acid is used. NO2, you have got it from the nitric acid in the trinitrotoluene. Okay. So it is used in making bombs also. It is used in the making of perfumes also. Imagine, wide range of uses. It is used in the bombs also. It is used in the perfumes also. Yes, that is your nitric acid. Okay. Then explosive, then oxidizer in rocket fuels, purification of gold and silver. As I told you, your nitric acid is so strong that it can even melt gold and silver. The nitric acid is so strong it can melt gold and silver metals also. Yeah, so it is used in the purification of that. Important, important, important. After nitrogen, now let us move to the phosphorus. Let us move to phosphorus. Now, your nitrogen, it exists as N2. Oxygen, it exists as O2. Can anyone tell me phosphorus, how does it exist? How does phosphorus exist? Yes? Is it P? Is it P5? Is it P2? Yes? How does phosphorus exist? Pavan, Netra, Sudarshan, Vishwanath, Yazira, Sai. How does phosphorus exist? Your nitrogen exists as N2. Oxygen exists as O2. Yes, diatomic. Yeah. How does your phosphorus exist? Anyone knows it? Sakti, how does phosphorus exist? Correct. Phosphorus is a polyatomic. It exists as P4. It exists as P4. What you can see over here, it is not a kite. Yeah, it is a structure of phosphorus. It is a structure of phosphorus. Yes, it is nothing but a structure of phosphorus. So this angle is 60 degrees. Remember, your phosphorus exists as a P4. Phosphorus exists as a P4. Okay. So allotropes. How many of you know what are allotropes? Yes. What are allotropes? Can anyone tell me? Allotropes. Allotropes. What is allotropes? Different. Allotrope. We have heard about allotropes, isn't it? Allotropes. What are the allotropes of carbon? You all know this. Come on, tell me. What are the allotropes of carbon? Yeah. What are the allotropes of carbon? Yes. Different form. Correct. Allotropes of carbon. Yes. Correct. Sudarshan. Vishnu. Yes. Carbon. Graphite is there. Diamond is there. Yes. Diamond is there. Graphite is there. It is basically same element is formed in different structure. Okay. Same element is formed with a different structure. That's it. Okay. That's it. Same element. It is formed in the different. It exists in the different structure. Okay. For example, yes, for example, carbon, diamond, graphite, then you have fullerene, that is a soccer ball, isn't it? It looks like a soccer ball. Yeah, it looks like a soccer ball, your fullerene. Yeah. So those are all allotropes. So different structural forms of a same element. So your white phosphorus, so your phosphorus, everyone write it down. Phosphorus has three isotopes. One is white. Come on, write it down, everyone. Important. White, red, black. White, red, black. So your phosphorus allotropes are three: white, red, and black. White, red, and black. So simple P4 is a white phosphorus that we have. Red phosphorus is a simple chain of P4, and the complex branch chain of P4 is a black phosphorus. Come on, write it down. Allotropes of phosphorus: white, red, and black. White, red, and black. White, red and black. White, red and black. Write it down everyone. White, red, black. Done? Okay. Now how do we get this phosphorus? Okay, white phosphorus. It is the least stable. White phosphorus. It is the least stable out of the three allotropes. So white phosphorus is the least stable. Come on, write it down. White phosphorus is the least stable. It is white, waxy solid, poisonous. What is that long word? Which long word? Chemiluminescence. Chemiluminescence. What? Luminescence means what? Yes. What is luminescence? Yeah. It glows, isn't it? It glows. So chemiluminescence, it is also same thing. Chemiluminescence. Okay. If you make it in the liquid form, it will glow. Okay. It will emit light. It will glow. It will glow. Okay. So phosphorus, it is poisonous, insoluble in water. If you react it with sodium hydroxide, you will get phosphene. Important, write it down. It is like a preparation of phosphine. You get the react phosphorus with sodium hydroxide, that is a base. What I am going to get? I am going to get PH3, that is phosphine. Okay, phosphine. Similarly, if I oxidize the phosphorus, I will get P4O10, phosphorus oxide, P4O10. Come on, write it down. Important, white phosphorus. Okay, so from white phosphorus, if I react it with the base, what I'm going to get? Phosphine and sodium hypophosphite. Phosphine and sodium hypophosphite. Come on, write it down everyone. Write it down and done in the chat box both the reaction. If I boil it with NaOH, what I'm going to get? Phosphine and sodium hypophosphite. And if I oxidize it, simply your phosphorus oxide. Simply your phosphorus oxide. Come on, write it down. Done. Okay. Now red phosphorus, I'll give you a quick comparison. I'll give you first quick comparison, then we'll come to this. Okay. I'll give you the quick comparison. Okay. So we have white phosphorus, we have red phosphorus, we have black, in which we have alpha form and the beta form. Okay. We have white, we have red, and we have alpha black, and we have the beta black. Remember, white, red, then alpha black and beta black. Okay. So how do we get the red phosphorus? Write it down everyone. If I have white phosphorus, write down in this form. If I heat the white phosphorus at 573 Kelvin, I get the red phosphorus. Yes, I get the red phosphorus. And Sakti, if I heat the red phosphorus, I'll get the black phosphorus. Okay, I'll get the red phosphorus. If I heat the white, I'll get the red. If I heat the red, I'll get the black. Okay. So in your reactive, you have white most reactive, then red most reactive, then black. Come on, write it down everyone. Your reactivity. White is least stable. Least stable means more reactive. If I heat white, Vishwanath, I'll get red. If I heat red, I'll get the black. Black phosphorus. Black phosphorus. If I heat the black, it will go in the air, nothing. Okay, white, red, black. White, red, and black. White, red, and black. Okay, reactivity. Then what we have, black phosphorus, you get it, is the alpha black and beta black. Okay, alpha black and beta black. Okay, so now look over here everyone, write down in this method. Okay, Sakti, look over here. If I have white phosphorus, if I heat it, I'll get the red phosphorus. correct? If I heat the red phosphorus, I do not get only black, I get, write it down, important, heating red, I'll get the alpha black. I'll get the alpha black. Okay. And if I want a beta black, I have to heat it the white. I have to heat white. Okay. So white, if I heat it around 573 Kelvin, I'll get the red. If I further heat red at 803 Kelvin, I'll get the alpha black. And if I heat white only at constant 473 Kelvin, I'll get the beta black. Come on, write it down. Important, important, mark it important. 100% it can come in the exam. Come on, write it down. White, heat it, make it red, heat it, alpha black. If I heat white at a constant temperature, 473, it will become beta black. Come on, write it down and done in the chat box. Come on, write it down and done in the chat box. Come on, done in the chat box, everyone. This is done, Parikshit is done. Sai, come on, done in the chat box. Vishwanath, Pavan is done. Netra, done. Okay, sure. You look at this comparison. Okay, you look at this comparison. Okay, right. Look at the stability. Okay, I'll assign the class assessment till then. I'll assign the class assessment. Okay, just give me a minute. Till then, you read the comparison. Read the comparison. I'll assign the class assessment. Just give me a minute. I'll assign the class assessment. Till then, you read it. Just give me a minute, everyone. I'm adding the class assessment. Let us go ahead just 5 minutes, then you start the class assessment. Class assessment, only 6 questions will be there and it will be completely theory. So it will hardly take you 5 minutes to complete the class assessment. Okay, hardly it will take you 5 minutes to complete the class assessment. We'll go little bit ahead. Okay, let me explain you little bit of phosphorus. Okay, phosphine will do tomorrow. Let me explain you phosphorus chloride. Look over here, everyone. Over here, your phosphorus. Okay, your phosphorus On reaction it with chlorine, it can form into two compounds. That is your PCl3 and PCl5. Okay, if I react phosphorus with the chlorine, okay, it can form into two compounds, that is PCl3 and PCl5. Okay, now remember this, your PCl5, okay, your PCl5 never exists as a PCl5. In the solid state, it always and always, write it down, PCl5 exists as ionic solid. PCl5 exists as a ionic in the solid state. It exists as a ionic. Write it down everyone. PCl5 exists as a ionic solid or ionic form. Okay. Now ionic form means what? It always want to form a dimer. It always want to form a dimer. So for becoming ionic, what happens? It aligns into PCl4 minus. PCl4 minus, write it down, important, PCl6 plus. Okay, just to form a, PCl4 plus, okay, PCl4 plus and PCl6 minus, just to form a dimer. Dimer means what? P2Cl10. So it does not exist into P2Cl10, it exists like this. It exists like this complex. In the, write it down, in the solid state. In the solid state, your PCl5 exists in the ionic form. Solid state, ionic form. Come on, write it down. Everyone, write it down and done in the chat box. Yes, write it down. Done. Done. Okay. Now we also have the structures of your phosphene and, oh, let me remove this image. Otherwise in the PDF you will have this image. Now your phosphorus, okay, now your phosphorus, if it is in the phosphoric acid form, okay, if it is in the phosphoric acid form, okay, if it is in the phosphoric acid form, like H3PO4, like H3PO4. Now remember this, I'll tell you the structure, okay, I'll tell you the structure. See, whenever you have H3PO4, H3PO2, whatever you have, always and always remember one thing, Netra, always and always one oxygen will be in the double bond form. Okay, one oxygen will be in the double bond form. Okay, in the remaining, I have, let us say, H3PO2. So one oxygen in double bond, one oxygen with the hydrogen, remaining hydrogen as it is. Remember this. Okay, suppose I have H3PO3. So it will be like this, P double bond O, then remaining two oxygen and the hydrogen with it. How many hydrogen are left? One hydrogen. So this will be H3PO3. Are you getting it? Similarly, if I have H3PO4, okay, same thing. I will have P double bond O, then I have more 3 oxygen, then add the hydrogen to it. Are you getting it, everyone? Yes? Is it clear? Okay. Now, is it clear, everyone? Come on, give me yes or no. Is it clear? Okay. Then your phosphine, you have phosphine. We'll do this in the next class. We'll start from the phosphine. But remember few of the facts of phosphine. Okay. Now, when you increase, okay, when you cool down phosphine, remember this, it solidifies your pH3 is nothing but phosphine. Okay. It solidifies around 140 Kelvin. Okay. It solidifies around 140 Kelvin. Okay. And it is in a liquid around 185 Kelvin. Write down this fact. This is not written in the PPT. Phosphine pH 3, it is liquid at 185 Kelvin. and it is solid at 140 Kelvin. Okay, it is solid at 140 Kelvin, it is liquid at 185 Kelvin. Done? Is it done, everyone? Okay.